So we're going to look at expanding and compressing the quadratic relations. Okay, so we're going to start with the ellipse, and essentially we're going to take a circle and compress along the x-axis and compress or expand along the y-axis. So if we think of how we compress or expand on the x, so if I had an f of x, so to compress along the x, really we would do f of x over a. So if you take a look at this expression here, this is really x over a. This is taking the x squared, expression, okay, and we're substituting in x over a squared, and we get the x squared over a squared in that way. Okay, so this is how the expansion compression along the x is going to show up. And we discussed this a little bit last day, in that the expansion and the transformations on the y, because they're with the y variable, they behave the same way as the transformations on the x. Because the transformations on the x are on the x variable. When we put the transformations with the y on the y variable, they behave the same way. So in this case here, when a is the denominator, the bigger this denominator, the greater the expansion. Okay, the smaller the denominator, the more you're compressing. Same with the b. Okay, the bigger the denominator here, the more you're expanding along y. The smaller the b, the more you're compressing along y. So we wanted to have some terminology here. So we're going to talk about the a and b are to do with x and y. However, there is a major and minor axes. And it's fairly straightforward. The major axis just means it's the longer axis. So if I have a ellipse in that way, the longer axis is along the horizontal, or x. If I have my ellipse in this direction, my major axis is along the y. Then that makes the minor axis the other axis. So here the major is y, minor is x. If it goes the other way, the major is x, the minor is y. Okay, so that's our major, minor axis. So we're just going to make sure that we keep the a with the x and the b with the y. So the a represents expansion and compression along the x, b represents expansion and compression along the y. So what is really useful then is to put it into this ellipse form. So here we have it equal to 1, which is kind of like that. And it's very easy to identify the expansion factor on the y. Okay, so that's b squared is 9, so b value is 3. It's a little bit tougher here. What we can think of this is that this is basically 2x squared. So we can really think, oh, that's a horizontal compression. Now, if we want to be consistent, we could do this. We could write it like this: x over 1/2 squared. Okay, so that tells us that it is a compression of 1/2 along the x-axis. And then when we look at the y here, this becomes y over 3 squared. Okay, so that means this is an expansion of 3 along the y-axis. Okay, and not only that, because we have our relative, or what we're starting with is 1. That means our initial radius is 1. We are going to end up with an x-axis radius of 0.5 or 1/2. So I'm going to maybe draw it like this. Okay, so I'm going to go 1/2 along the x, and then I can just go expand by 3. So 1, 2. Well, let's go up a little higher. 1, 2, 3. So we'll have 3 along the y-axis, and I'm going to go down 3. Okay, so these represent then my vertices of my ellipse. And then I should just sketch in my ellipse. It's just a ellipse that's going to look like this and hit those vertices. Okay. So again, we can always check this. The nice thing now is that we can actually graph these on Desmos and check these values. So this is what it looks like. This is 4x squared plus 9 over y over 9 is equal to 1. The graph is going to look like this. It's going to have a vertical major axis. The vertical radius is going to be 1, 2, 3 based on that 3 here. And my horizontal is my minor axis. My horizontal radius is going to be 1/2 based on that 1/2 here. Okay, so that was a little bit tricky. We'll get back to one of those again. Let's do the easier ones with the parabolas. We already know what parabolas look like. Okay, we already know that this A value is going to expand and compress along the y-axis. Just so that you guys can see, if I'm going to do a vertical expansion, now we don't want to do this with parabolas, but if we want to be consistent, we could show this as y over a equals x squared, and we could say that this then is a vertical expansion that is along the y. So this is although it's divide, remember that's opposite, and when we put it on this side, it's going to be times. Okay, so when it's on the y side, it's going to do the opposite. So if I divide by a, I expand by a. Okay, but with parabolas, we're more familiar with it in this form. Now, when we switch it around to a horizontal parabola, okay, parabola opening sideways, as long as I keep the same format, that A here is going to be a vertical expansion and compression. Sorry, a horizontal expansion and compression. So it's going to expand and compress this way. Okay, and since the x is on this side, the A is on this side, on the opposite side, it's going to be, if it's a big A, it's going to expand. If it's a small a, it's going to compress. Just like if I put it on the side with the x, a big A here would expand, a small a would then compress. Okay, so again, we could write it like this, but we are probably more familiar with this form, so I would recommend keeping it in that form. Okay, so that A value is going to expand and compress horizontally. This one will expand and compress vertically. So when we look at, y equals x squared, this is a horizontal compression. Sorry, my mistake, a vertical compression. Okay, so when we show it on the x side, it's going to be exactly what we see. And then if we put it on the y side, okay, it's going to be 4y. This means it's a horizontal, vertical. Instead of timesing by 4, since it's with the y, it's going to do the opposite, or compress by 4. Okay, so we could frame it like this. However, this is probably much easier for us to interpret because we're much more familiar with that.